topics. Let's work on problem one. So for problem one, what's the problem? Matt is going to a statistical conference. He wants to estimate the number of attendees. So he randomly pick a sample of 64 people. So the sample is 64 people. Or he randomly sampled 64 people and at the poster station and put stickers on their name tag. So like 64 was put on name tag, and then he picked a sample of 67 people. And within the 67 people, he found that 21 are being tagged. So we want to estimate the population, the total number of attendees at this session. So one way to think about it is to think about like the proportion. So we know that in order to make a good estimation, we assume that our sample is good. So like there's roughly if there's only like 67 people, there's roughly 21 who are tagged. So if we are given that 64 are tagged, what's the number of population? Like we can set X to be the number of total people, or the total number of people. Switch. Okay. So we know that X is equal to 67 times 64 over 21. So we might need to make a floor function on that to make an integer, because we can't like cut people in half. And for second problem, the problem is I perform 900 independent Bernoulli trial with individual success probability of 0.01, and I perform n equals to 900 Bernoulli trials. So we want to estimate we want to calculate the exact probability of 5 success. So remember, like binomial distribution is basically a lot of Bernoulli trials combined. So if we want, we perform like 900 independent Bernoulli trials. It's just like a binomial distribution. And we know that for binomial distribution, the formula is n choose k over p, which is the success rate, the ratio for success, times the number of success. So like k is number of success, n is like total numbers, and p is probability of success. So that's our binomial distribution. We need for like x equal to k, we need like k success and n minus k failure, and we need to choose out of n k success, and each success has its own probability, so we times that many, and then the rest of them has to be non-success. So like for this question, we want k equal to 5 success. So the answer would be 900, choose 5, because 900 is our n, and p is 0.01 to the fifth, because the success is fifth. And the probability of failing is just 1 minus 0.01, which is 0.99 to the 895. That comes from 900 minus 5. If you plug in a calculator, this is roughly 0.06035. And for part B, we are asked to use the Poisson PMF to calculate the probability of exactly 5 success. So for Poisson distribution, we know that Poisson, we need to input a parameter lambda, which is the mean or like expected value of that. So it is equal to n times p, which is 100.0.01 equal to 9 in this case. And then like to remember the formula for Poisson distribution is what is lambda to the case times e to the negative lambda over k factorial. So in this case, we know that k is equal to 5. So what's the probability of x equal to 5? That's just lambda. And lambda here, we have already calculated is equal to 9. So it's 9 to the k times e to the 9th over k factorial. And we know k is 5. So it's just 9 to the 5 e to the negative 9 over 5 factorial. And if you plug in into calculator, this is roughly 0.06073. And look at our solution from part A and part B. These two are very similar. So that means that if we use Poisson distribution to estimate a binomial, in this context, A works well because these two numbers are pretty close.